We present physics-guided and geometry-aware regularization for source-only cross-weather LiDAR semantic segmentation. In rain, snow, and fog, simple point jittering or dropping can break local shape and remove boundary points, so nearby classes get mixed up, for example bus versus building, building versus fence. Because it does not consider LiDAR scan continuity and fragile regions, thin objects, far-range sparse areas, the predictions become unstable. We first create realistic hard samples using selective jittering, plus physics-guided snow-like simulation. Then geometry cues, scan continuity, plus local KNN, guide in our L-based region drop policy to preserve fragile boundaries and sparse regions. During training, we learn only from the source dataset, Semantic, without using any target labels. We replace global KNN with local window KNN and circular padding to preserve true neighbors across the 0-360 degrees LiDAR seam. Keeps neighborhood geometry consistent, leading to more reliable geometry cues and fewer boundary errors. These geometry cues guide in our L-based region drop policy to avoid removing critical boundary and sparse region points. As a result, point dropping becomes selective and boundary aware, improving robustness under adverse weather. We add snow-like deposition after selective jittering to create physically plausible hard samples while keeping the global scene layout. This helps the model learn stable features for safety-critical classes, for example, car, person, and/or strong weather corruption. We compare the predictions of models trained on Semantic, including data-centric augmentation in our method. However, the source domain is already clean, so the room for improvement is limited, and the performance gap on Semantic is usually small. We compare our method with LiDAR weather, a representative data-centric augmentation baseline, on the semantics dataset. Our method stabilizes predictions in fog, rain, and snow by preserving boundary cues and thin object points. For more information about our research, please visit our lab website. Thank you for watching.